Welcome to ActiveMQ Essentials. I'm Jamie Goodyear. Today we're going to pop open the hood of our ActiveMQ broker and take a look at the message cursor. That's the mechanism that gets all of our messages to our consumer clients. Up next. Okay, let's dive in. So ActiveMQ is effectively just an implementation of a JMS provider, the provider being the broker. At the high level, we have producers, which are going to send messages, JMS, into the broker, where we'll usually persist them into a message store, be it KahaDB or some other database. And then a consumer is effectively registering or subscribing to pull those messages. Now, our destinations could be a topic or it could be a queue. We have a video explaining the difference between the two, but effectively what we're saying is a message goes into your mailbox and you connect in and you grab that message and take it out. Now, one of the big concerns we have here is resource usage inside of the broker. We can think of it as being that the producer, when it's sending messages into these various destinations, in our diagram we have destination A and B, we send into a construct we call a cursor. Think of it as being like a cache, in-memory cache, that holds those message references so that the consumer can quickly grab those and pull them out. We have a couple of different strategies for how we implement this particular model. And an important part that we have to put in here is that each one of these are going to be using something called a dispatch queue. So underneath the hood, what's going on is we have these cursors, so pending cursor for each destination. And we have a dispatch queue, which is the actual part the consumer is pulling messages out of to be consumed. Now, the interactions between the two and how they talk to the message store, this is where our differentiations will occur. So let's look at the store cursor. This is the default way that ActiveMQ 5 going forward works. Broker administrators do not need to specifically configure this behavior for any of the destinations. However, it is possible for you to go in and set these values. We'll take a look at some configuration samples after all of these various cursors have been explained. Persistent messages are saved into the message store, and all the non-persistent messages are passed to a pending cursor, which has a file-based backup that allows that to work. We'll take a look at the file cursor toward the end of the video, so we'll go over those details. The model we're going to show you first is for fast consumer, in which inbound messages are coming in, and we're going to send those messages down to that message store if they are being persisted, and the rest goes into the cache. Now, this is all the memory area here. In the case that we're doing fast consumers, that message is going to go directly into the dispatch queue because the consumer in this model is fast enough to keep up with the inbound messages. So if it's sending in 10 per minute, it's able to consume those 10 per minute. So nothing's really sticking around in the memory area. If this was to slow down, i.e. Or speed up the number of messages coming in, so say we normally can only handle 10 messages per minute, and now we're sending 20 in, now we're going to start backing up, and you can imagine over time, the broker will run out of resources. This is where the store cursor provides a bit of a hybrid failover internally to itself, where it uses what we call the pending cursor. So what's a little different here is that as the messages come in, we're still going down to that message store and persisting your message. But we also are allowing a pending cursor to fetch buffering in from the store, from that slower disk store over here to the database, into memory, such that the dispatch queue can page in from our pending cursor those messages. So that means when the slower consumer or consumer just can't keep up with the amount of messages coming in, we're giving the broker the ability to page in these messages. So not everything needs to be in memory at once. So if 1,000 messages are coming in and we're getting them all down to the store, we don't have to keep all 1,000 in RAM all the time for it to be consumed. We can say get the first 990 down to disk, or all 1,000 actually goes down to disk, but the first 10 gets over to the consumer real quick, and then the rest we're paging in. So that way it's able to eat the elephant one bite at a time to get all that processed out. This allows the broker to be a lot more stable and scalable because of this, because we don't have to have memory sizes to reach any amount of pending that you could have at a given time. Now, this particular improvement we did for AMQ5 going forward is a reaction to how ActiveMQ and before worked, which was effectively using a vmCursor. We keep that capability, however, in AMQ5 going forward. What this means is that you can use this strategy where you want to populate messages coming into the system. We're still going to be able to persist down to the message store, but we're also going to immediately pass that message into the pending cursor. So it's still in memory and feeding that dispatch queue. So as consumer is pulling messages out, it's going to be pulling from the pending cursor. This is really good where we have really, really fast consumers, and we know we want to keep most of this stuff in memory as much as possible. We only apply this when consumers are consistently fast. So if it's going to be a consumer that would get slow at times, we don't want to be using that because the broker resources will get used really quickly. We also, in the cases here that when consumers become slow or inactive for long periods of time, this can start impacting how the resources are going to be available. You can imagine if this is a topic and some consumers only check in periodically, it's possible that a lot of resources get used if we have a burst of topic messages landing. The last strategy we want to talk about is called the file-based cursor. This is adding in yet another layer to how this model works. What this one is, it employs temporary files as a paging space for quick access to messages. This allows pending cursor to grow within a limit. It also means that this approach is taken instead of falling back to a slow message store where we saw the pending cursor would feed from the message store. We now have the ability for the pending cursor to page in and out to the local temp file. The idea here is that if you were going and paging in from the message store, the idea is that that's somewhat of a slow connection. Ideally, we always want our message store to be really, really fast. So be it KahaDB or some other database, you want that network connection to be fast, its disks to be fast, all access and read writes to it to be very, very quick. We're using this in the case where we're like, yeah, it's there, but somewhat slow. And sometimes it's faster just to page out to a local temp file to be able to grab those files. I will note that when you're using the store-based cursor, we are going to use those temp files for anything that's a non-persistent message. So if it didn't have to go to that message store originally, it's going to go onto that temp file if we need to have that space. So that's what's going on there. So with all this said, let's take a look at some configuration examples for how you can set this up on your broker. In our show notes below, you'll find a link to this repo. Inside of it, we include 3 sample configurations. Our first one is for the store cursor. We begin with the standard ActiveMQ configuration file that you'll find in the conf directory. And inside of it, we'll go down to our broker element. That's where you'll set your broker name and where your data directory lives. Inside of it, we need to look at the destination policy. Inside of it, you'll find a policy map, which contains policy entries. When you want to configure or specify exactly what our policies are for topics or for queues, you'll need to add in a policy entry. Now, in our case, we are going to use policy entries that are for all topics or for all queues. That's what this particular symbol is meaning. We don't use a asterisk like you would use for most regexes. We use the greater than sign. But you can put in here per destination, so a particular topic name or a particular destination queue name, to set which one of our policies you'd like to set up. Now in here, we already have by default, we had the pending message limit strategy set on our topic. But what I'm showing in here is where you would normally put in your subscriber policy. There's actually a pair of them you can use for a topic. The main pending subscriber policy and then your durable subscriber policy. Because it's a default setting, you do not need to set your cursor store here. However, if you want to have a durable store cursor, you're going to have to specifically enable that. Similarly, on queues, you'll go in and set your pending queue policy, and you can say it's a store cursor. Again, this is default values. You do not have to put that in there to be using those. If you were to go in here though, and you want to set up to use a different strategy as your default, you still may want to go in and have specific destinations set up to use a store cursor, hence why we're showing those. Let's take a look at the vmCursor. So again, we're taking a vanilla ActiveMQ configuration file and we go down to the broker configuration, destination policy, policy map. And inside the entries, you're going to see a couple of settings here. In the case of topics, we'll set the pending subscriber policy to vmCursor, and then we'll use vmDurable cursor for topics. In the case of a queue, we'll set the pending queue policy to vmQCursor. Similarly, for the file cursor, we'll go into the same locations and we'll set file cursor file durable subscriber cursor, or file queue cursor. These configurations are relatively easy to add in, but you do need to have this set up in your configuration file on the broker side. And once you have this set up, this is something you have to manage per destination or set for all destinations. So it's something you need to be aware of and you need to work it out, and this is part of your overall architecture. If you have questions on how you do that for your specific setup, always feel free to reach out to us. This is the kind of things that we do. On that note, however, I would like to point out that the store cursor is what you should start with. Once your architecture or your application has shown you its requirements, that's when you should consider, do you need to use the vmCursor, i.e. you need to be all in memory, you don't want to touch disk, or if you discover that you need to go all the way to having that file cursor due to particularly slow consumers, connections, etc. But this is something that your application testing and fine-tuning will help illustrate you need to have it. Okay, on that note, we hope that you found this episode on ActiveMQ message cursor to be enlightening. We're at that time though now where we have to say goodbye to you again from this episode. Please like and subscribe to our channel and hit that notification bell to learn about our latest episodes. Have a great day. Cheers.